Hi there. So in this screencast, we're going to be talking about a little bit more of error handling in C++ code. And so yeah, in the last screencast, we were talking about this interface function, which it's basically just calling this predict one to max neighbors matrix subroutine, which is written in C++, and it returns this error status code. We wrote this if statement here, which tests for a particular error condition and stops R with an error after having run the algorithm if that algorithm detects that there was an error. But there's a certain number of conditions that the algorithm assumes in the inputs, and so that's something that you need to also test for in your C++ code. So, for example, if we go and look at this knn.cpp file, well, we see that this predict one to max neighbors matrix, it assumes that the inputs are and the number of rows in the input matrix is n train, and the number of columns is n column number of futures, right? And then it assumes that this train label pointer, it's an array of n train items. So what if that's not true? It could be very well that your R code passes in two vectors which are completely different sizes. And so what happens in that case? So let's go to the R command line and test for that. Actually, let's go to the test file. And so let's write a new test that block. Error when n row x is not equal to length of y, right? So that's the error that we were just talking about. And the n row of x here, this is what happens when we pass the number of items in the train set here. But what if we pass instead of here, what if we pass the first 10 items there, and here are the first 20 items? I don't know, maybe that's gonna give a sensible result, maybe not, right? So sorry, so let's say when n row x equals 10, and yeah, well, I guess let's just do that and see what that gives us. So that's still giving us no test data, so let's get rid of that. That's the same error that we saw last time. And so now we're kind of wondering, like, why is this giving us any answer at all? Because it's kind of strange that it would even attempt to do something when the things are not really the right size, right? So another test that you might want to write is, how about error when weight's not correct size, or actually when weights are not error for negative weights, right? So these are two different kinds of errors. This is the error in the size of the arguments, and here's the error in the values of the arguments. So here, let's put these back to the right sizes here. But here, what if we did, gave everything a weight of -1 instead of 1? So it doesn't really make sense to have a weight of -1, or any kind of actually even a 0 weight. It really doesn't make sense, so how about we just use 0 and see what happens. So here we get a bunch of infinities as predictions, so that's kind of nans and infinities, and so that's not really what we want. What we want is error for non-positive weights. Actually, we should say 0 weights. So here, the error message that we would expect is that number number of observation n row x. Well, so I mean, to have a I guess a more informative message, we should look at what are the actual argument names here. Argument names are train inputs mat, so we should use that there. Nrow train inputs mat equals 10, but ncall but length yvec, so that the argument name there is train label vec equals let's say but this equals 20, but they should be equal, right? So that's a very informative error message that we can write in the C++ code. And so the error message that we would expect here is weights should be positive, right? So it's always good to tell the user what the values they should use should be. So let's go to our C++ code and try to detect those error conditions. So going to the interface file, this is where we need to do it before we call this subroutine, right? So here we need to do it somewhere between the start of this call and the place where we call the subroutine. So probably the best place to do it is right in the beginning. So first thing we could do is say if train inputs mat.nrow not equal to train label vec length, then stop with this message. What is the message again? Let's go back to our test to make sure that we get it right. It's this one. And let's just copy it so we get it right the first time. Here I think we can use substitution. So here we go. Set train inputs mat nrow for that first %d, and then train label vec dot length for that second %d. So already, let's see if that test is going to pass. So here we're recompiling. Alright, so it says it threw an error with an unexpected message. It said nrow train inputs mat equals 10. I don't know, those messages look the same to me. That's odd. Yeah, the reason why is that when we're doing the test that, here we have a, in this expect error thing, there's this argument, so the second argument here is, as you can see in the completion and the mini buffer at the bottom there, it's interpreted by default as a regexp. So there's this argument fixed equals true if you want to interpret it as a character string rather than a regex. And so when it's a regex, these parentheses have a special meaning, so it's not going to be an exact match. So let's try to recompile and retest and see if that works. Right, so actually we don't need to recompile, it just reinstalls the package. And now it's that second test that fails. Error for 0 weights. So how do we fix that? Well, we need to edit the C code and put an error message when we have 0 weights. When we have non-positive weights, right? So here, the idea is that in the weight vector, we have if train weight vec equals 0, and I think we can do dot any, then we can stop weights should be positive. Let's see if that works. Okay, we don't, that does not work, right? So let's do a Google search to find that. Rcpp docs logical vector methods ini. Logical operations, very good. So how about ini? That's what we want, all ini. So so yeah, here actually it's again it's not a method, but it's a function that we need to call. So let's try that. So if any, alright, actually it's not, that's not the right condition, right? So condition should be if any are less than or equal to 0, right? Oops. Not just equal to 0. Uh-oh. So I got an error because I stopped that compilation in the middle of installation. So it says try removing a lock in Rcpp. So let's try that. Here I'm going to show how to do that from within R. Here, that's easy. You just do unlink and you give it that thing and you say recursive equals true to delete that directory recursively, and then let's try to recompile. Recompile and retest, right? So let's see what happened now. Could envision to bool is forbidden. What is this? Right, so I think what we need to do is we actually need to create the logical vector, right? So it's not exactly the same as in C++, as in R code. Here, the types sometimes, you know, let's call this logical vector is not logical vector not positive equals this if any not positive. So let's see if that works. You know, so in the C++, you know, you can't write everything in exactly the same way you would write it with R. So let's see. Forbidden conversion. So same thing. What happened? Acquired from here, right? So yeah, I guess, yeah, the other thing is that if is true, right? So in the example, we have to explicitly create a boolean from the logical vector, right? So let's try that. So if any is true, not positive, is that right? No matching function for call is true. So here we're doing is, yeah, so yeah, it should be the other way around. If is true, any not positive. That's right. So let's try that. That compiles. Very good. Tests run and they pass. So that means that we are stopping with an error message that tells the user that they've provided bad inputs to our C++ interface function. So these are not exhaustive error messages, right? So here I've only created like 2 examples of things that could possibly go wrong. But you should try to anticipate all of the possible ways that the user could provide you with numeric matrices, numeric vectors, all these different kind of arguments that might not make sense for your machine learning algorithm. And so you should try to detect those conditions before calling the subroutine. Just like these 2 examples, you can use these Rcpp functions to detect when the user has provided bad data, and you should stop before you call your subroutine, right? So then you won't be returning any nonsensical results, and you'll probably avoid crashing, so because sometimes if you pass as inputs which are the wrong size to a subroutine which assumes different size, you might get some like out of bounds memory access issues, and so you might actually segfault R. And so it's really important to do those kind of checks before calling your subroutine. Especially checks on the size of things. Anyway, so thanks for listening. I hope you learned a little bit about error checking and testing.